Namaste dear students, I am B.G.Shinde sir and we are discussing chapter number 3 Kinetic Theory of Gases and Radiation of 12th Standard Physics. Today we see lecture number 3 and today's topic is RMS velocity and interpretation of temperature in kinetic energy. So listen this lecture up to end. Also tell your friends about our lectures and share these lectures and subscribe. Tell the friends to subscribe our YouTube channel so that you can get automatically new videos in your mobile. So let us start this topic RMS velocity. So first I will tell you what is meaning of RMS velocity. RMS stands for root mean square. It is a root mean square velocity. It is denoted by VRMS. Now what is meaning of VRMS? What is the meaning of the root mean square velocity? It is the mean of it is the square root of mean of the squares of the velocities of the gas molecules, and this is called the RMS velocity. The mean value of the square root of mean value of the velocities of the molecules of the gas is called the root mean square velocity. This is definition, this is meaning of the root mean square velocity. So this is equal to under root of v1 square plus v2 square plus Vn square divided by n. If V1, V2, V3 and Vn are velocities of the molecules of the gas, and if there are n number of molecules, then the mean value of this square of the velocities is this value, and its under root is called the root mean square velocity. This is meaning of the RMS velocity. Now we find expression for RMS velocity. First we write expression for pressure of the gas, and it is P is equal to Nm V square bar divided by 3V. Now this V is velocity. V is velocity of the molecules of the gas. Capital V is volume of the gas. This is volume of the gas. N is number of molecules of the gas. M is mass of each molecule of the gas. So start from this expression for the pressure of the gas and let us find RMS velocity. So using this formula we can write V square bar, it is equal to 3PV divided by N into M. Now in this formula we put value PV is equal to nRT. This is ideal gas equation. So V square bar is equal to 3nRT upon n into m. Now here n upon m, n upon capital M is equal to Na, because number of moles is equal to number of molecules divided by Na. Na means the number of molecules for 1 mole of the gas. So using this formula we can put this value means let us put this value n is equal to n upon na in this equation. So we can write 3 RT upon na multiplied by m. So this is v square bar. So we get this v square bar. Now here let us put this na multiplied by m. Na into m is equal to molar mass. Now what is this Na into m? It is the molar mass. Na into m, it is m0, it is called molar mass. So this equation will become v square bar is equal to 3RT. It is divided by m0. So we get this equation v square bar equal to 3RT upon m0. Now if you take square root of this is v square bar, it is equal to 3RT upon m0 and its square root, and this is RMS velocity. This is the expression for RMS velocity of the ideal gas. So this is the expression for RMS velocity. You can determine RMS velocity of oxygen, RMS velocity of the nitrogen, of all real gases by using this formula, and from this formula you can also write V RMS is directly proportional to under root of T, because here this R is a universal gas constant, it is a constant value. M0, it is a molar mass. These numbers or this R and M0 are constant, and therefore VRMS will be directly proportional to under root of T. So this is the conclusion of this article. This is the expression for the RMS velocity. Now, for sound, velocity of the sound is given by one formula. Vs is equal to under root of gamma RT upon m0. This is a velocity, this is the speed of sound, and where this gamma is equal to Cp upon Cv. It is also called adiabatic ratio, or this is ratio of the specific heat at constant pressure to the specific heat at constant volume, and this value of gamma is less than 3 for sound, and since it is less than 3 for sound, from this equation 1 and also from equation 2, it is clear that the speed of sound is less than the speed of the molecules of the gas. So average speed of the molecules of the gas is always greater than the speed of sound. This is also one of the conclusions of this article. So this is all about the RMS velocity. तर हे RMS velocity चा आपण एक्सप्रेशन फाइंड केलं. तर सर्वांनी बोर्डवरचं जे लिहिलेलं असतं ते आपण नोटबुकवर लिहत चला, किंवा स्क्रीनशॉट घेऊन ते आपण आपल्या नोटबुकवर लिहा, म्हणजे आपल्याला अजून जास्त व्यवस्थित समजेल, आपला चांगला अभ्यास होईल. बोर्डवर जे लिहिलेलं असतं ते जरूर लिहत चला. तर आता now let us see interpretation of the temperature in kinetic energy. Now for this purpose also we see the formula P is equal to Nm V square bar, and it is divided by 3V. This is expression for pressure. Now let us rearrange this expression. We write this expression as PV is equal to N upon 3 multiplied by 1/2 mv square bar and this will be multiplied by 2. Means just rearrange this equation. म्हणजे मी काय केलं फक्त हा v इकडे आणला, नंतर n/3 साइडला दिला, नंतर इकडे 1/2 mv स्क्वेअर ला मल्टिप्लाय केला म्हणून इथे 2 मल्टिप्लाय केला, म्हणजे हा 2 कॅन्सल होऊन जातो आणि पुन्हा सेम इक्वेशन आपल्याला मिळतात. सो जस्ट रिअरेंज दिस इक्वेशन, अबव इक्वेशन. सो now in this equation 1 or in this formula, this 1/2 mv square bar is kinetic energy, average kinetic energy of a molecule of the gas. And we know that for ideal gas, if there is an ideal gas, potential energy of the ideal gas is equal to 0, and therefore the internal energy of gas or internal energy of this ideal gas is purely kinetic energy, and therefore total energy of the gas will be given by number of molecules of the gas multiplied by kinetic energy of one molecule of the gas. So this is total energy of the gas. So we can write this equation as PV is equal to 2/3 multiplied by total energy. It is denoted by capital E. So this is E, because n into 1/2 mv square bar. This is 1/2 mv square bar multiplied by n, and it is equal to E. So we write this equation as PV equal to 2/3 multiplied by E. Now we can write this equation again as E equal to 3/2 PV. Say this is equation number 2. Means this is the total energy of the gas. Total energy of all the molecules of the gas will be given by equation 2. Now again use ideal gas equation NKB into T. This is ideal gas equation in terms of the Boltzmann constant. This Kb is called the Boltzmann constant. In first lecture we have obtained this relation. You see that lecture. So put this value here. So E is equal to 3/2 NKBT, and therefore energy, total energy per molecule is equal to 3/2 Kb into T. So this is the expression for total energy per molecule. So we can say that kinetic energy per molecule depends upon temperature, and kinetic energy or this total energy per molecule of the gas is directly proportional to absolute temperature. This is the interpretation of the temperature in kinetic energy. Actually this total energy is kinetic energy here. Means here we have seen that this kinetic energy, this is the kinetic energy 1/2 mv square bar. Potential energy is 0, and therefore total energy is kinetic energy. And so this energy is total energy per molecule of the gas, and this energy is also kinetic energy per molecule of the gas, and this kinetic energy per molecule of the gas will be directly proportional to, it is directly proportional to T, absolute temperature, because this Kb is a constant number. So this is interpretation of temperature in a kinetic energy. So this is end of today's topic. So dear students, write all the points which are given on the board in your notebook. तर आपल्या नोटबुक मध्ये प्रत्येकाने सर्व पॉइंट्स लिहत चला, हे वाचत चला, पुन्हा पुन्हा रिव्हिजन करा, अभ्यास करा, आणि म्हणजे तुम्हाला चांगलं नॉलेज मिळेल आणि तुम्हाला चांगले मार्क्स हे एक्झाम मध्ये मिळू शकतात. आणि हे सर्व जे बुक मध्ये आपले जे स्टेट बोर्डचे जे बुक आहे ते सी